Example 5, consider the letters below, and you see some Scrabble tiles spelling out thank you. How many permutations of the letters are there? Permutations means order. Okay, how many different ways of ordering those letters? So we're ordering all of them, right? How many letters are there? 8. And so if we think of this as a fundamental counting principle problem, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but you're probably just going to call this a factorial, right? So good chance to practice your factorial button. Where is my calculator? Oh, calculator right here. Eight factorial, 40,320. B, how many ways are there to select 2 of the letters? I probably should have said, instead of select, order, just to make it obvious that the order of the letters is important. Later, we'll have problems where the order isn't important, but right now it is, okay? And so the way I like to think about this is I'm taking a group out of a larger group, and order matters. So out of the 8, I'm going to take 2 of them. So you can write it several different ways. You can write it like P8, 2, or you might see it as 8 NPR2, 8P2. What's important is you see those 2 numbers, 8 and 2, and you know it's a permutation, so you know that the order matters. 8 NPR2 is 56, okay? Now, maybe you knew how to do that in your head because it's a partial factorial. It's 2 blanks, 8 times 7. That's a partial factorial. The first 2 parts of that factorial, 8 times 7, you're going to get 56. Number 6, this is a very common question. 8 runners are in a race. In how many ways could the runners place first, second, and third? So we're taking a group out of a group. How many out of how many? 3 out of 8. Does order matter? Would you rather get first place than second place? Well, sure, order matters. Order makes a difference. And so this is a simple permutation problem, 8P3. 8P3 is 336, or 8 times 7 times 6. Because it's the first 3 pieces of the factorial. 7, a pet store currently has 4 dogs and 3 cats for sale. In how many ways can the pets be arranged? Part A, in a row of 7 crates. So the problem's kind of tricky, I guess, but there are 7 crates. So I like to draw this out as 7 blanks. Looks like a fundamental counting principle problem to me. Okay? And so there aren't any restrictions placed on this problem right here. And so you need to think about, well, how many ways are there of putting an animal in that first crate? 7. Okay? And then once I pick one and put him in the crate, how many ways for the second one? 6 and 5 and 4 and 3 and 2 and 1. Okay? That's 7 factorial. 7 factorial. 5,040. Part B, what if the dogs and cats are alternated? So I want you to get in the habit of drawing it out, okay? Some people will resist and it'll get kind of difficult, but think about it. If that is true, then it has to go dog, cat, dog, cat, dog, cat, dog. It has to be like that. There's 4 dogs and 3 cats, so if you're going to fill up the 7 crates and alternate like that, it has to be that way. First one has to have a dog, second one has to have a cat, okay? So think about it like blanks If you know that a dog has to be first, how many choices are there to pick a dog in that first crate? 4. 4. And then let's stay with the dogs. You know a dog has to go there, and there, and there. Okay? So we've got a factorial, 4 factorial for the dogs. And then we do kind of the same thing for the cats. I know there's 3 ways to pick the first cat, and then 2 ways, and then 1 way. So if you want to rewrite it, we're looking at 4 factorial times 3 factorial. It's going to be 4 factorial times 3 factorial, or multiply it all out if you want to. But we can go 4 factorial, 3 factorial, and you're getting 144. However you slice it, you're going to get 144. Part C says, what if all dogs are next to each other and all cats are next to each other? Okay, so this one's a little bit trickier. So very similar. They're saying all the dogs are together. But here's the problem. Do you see another possibility? Maybe I put the dogs on the left, but maybe I put the cats on the left. And that brings me to an important point. Earlier I told you that when you see the word and, we think about the word times. So and means times or multiply. Let's say this. That's the fundamental counting principle. But we've got another concept that comes up all the time when you see the word or. We're going to add. Okay, you need to learn that right there as quickly as possible because it comes up all the time. And means times and or means plus. So learn that as quickly as possible. So once we start solving this out, you can look at a factorial here and a factorial here. It's really going to be very similar because we've got a 4 factorial and a 3 factorial, which we just did up in the last problem. 4 factorial times 3 factorial was 144, right? 144. But the difference is we're going to have another 144 right here because we're going to have the same thing, this 3 factorial times this 4 factorial. So we've got 144 plus 144 equals 288. Kind of a tricky question there. Part D, in how many ways can 1 dog and 1 cat be selected? How many blanks are there in this problem? 2, exactly. Do you see the word and? Okay, remember, and means times, so I only see 2 blanks. So I draw out the blanks. Some of these problems are really tricky. So draw it out. Try to simplify it when you can. 1 dog and 1 cat. So how many ways are there of picking 1 dog? 4. How many ways are there of picking 1 cat? 3. So this answer, 4 times 3, is 12.